All right, back to stoichiometry. Let's look at another type of reaction. Let's look at this reaction. It's a shame we're not at school to be able to do this. Copper plus silver nitrate. Silver nitrate, silver is +1, nitrate is -1, -1. These charges cancel out. This is a solution, solid. And then you recognize it's a single replacement reaction. So the copper is more reactive than silver. We'll get copper nitrate. Copper has a +2 charge. All right, so we have a solution of, oops, excuse me. And then we're also gonna get some silver. Need to balance that. Put 2 here, 2 nitrates. Put a 2 here. All right, so here's our balanced chemical equation. We did this earlier in the year. Maybe you remember placing some copper and silver nitrate. I think we did that. Anyhow, so let's imagine this. Let's say we have tons of copper. Copper's in excess. And we have a solution of silver nitrate. Let's say we have 22 mils of this, and it's a 1.5 molar solution, okay? So in this beaker here, we have a solution, excuse me, we have a copper wire, like that, and it's in a solution of silver nitrate. All right, so there's our copper, and there's silver nitrate in there. Okay, so let's see if we can figure out, let's figure out this. How many grams of silver we're gonna be producing? All right, so that's in excess. Let's start with what's given. Now, when given 2 things, always start with volume. So let's start with 22 mils. So 22 mils of the solution. Now remember, molarity is moles per liter. So we got to convert mils to liters. So there's 1,000 milliliters in a liter. Mils cancel out. Now we're just going to be clever with this molarity. It's 1. We can replace that capital M with moles per liter. We need the liter to go in the denominator. And then we have 1.5 moles of silver nitrate. Liters cancel out. Okay? So now we have moles of silver nitrate. Now we can go to moles of silver. In this case, it's a 2-to-2 ratio, which is 1-to-1, but I'd still like you to show this 2, because that's pretty significant. That shows that you understand where this ratio comes from. That 2 is there. And then, of course, that's going to give us 2 moles of silver. So the moles of silver nitrate will cancel out. All right, one more step. We're trying to figure out grams of silver. If we wanted to figure out number of atoms, we put Avogadro's number there. Grams, so we're going to use the atomic mass of silver, which is 107.87, I think. Let's just go with that. 1 mole silver. Silver cancels out. And let's do a little calculation. Let's make sure we get the right answer. 2 sig figs again. Seems like we're always using 2 sig figs, so, oops, excuse me. So we get 22 divided by 1,000 times 1.5, see what that equals, and then times by 107.87. We're going to round that to 2 sig figs. So we're going to get, we're not rich, but we're going to get 3.6 grams of silver. All right, so let's just review a couple things here. You want to write a balanced chemical equation. You want to write down what's given, what you're trying to find. Start with what's given. If given a volume, start with volume. In this case, we need to convert it to liters. Again, this is the new part. This mole ratio that comes from the balanced chemical equation. Just round off proper number of sig figs, and don't forget that unit. And you should be catching on to this now. I'll give you lots of practice. All right, thanks.